Hello everyone, this is our session 3 on vectors. We are starting with the first exercise 5.1. Okay, so I'll just do some important sums from this exercise. Let us begin. Okay, so we are starting with exercise 5.1. Question 3. Okay, so question 3 says OABCDE is a regular hexagon. The points A and B have position vectors A bar and B bar referring to the origin O. Find in terms of A bar and B bar the position vectors of C, D and E. Basically OC, OD and OE. Okay, so let us first draw a regular hexagon. Okay. So we have okay. So this we will name as OA, B, C, D and E. Okay, out of which OA and AB are given to you, that is A bar and B bar, and OB we are going to join. So let us join OB. Then we will join AD, OC and EB. AD, OC and EB. Basically, these are the three diagonals of the hexagon meeting at point M. So you can say join diagonals of the hexagon meeting at point M. Okay, now what is given to us? OA bar, okay, is equal to A bar is given, and OB bar is equal to B bar given. Okay, let AD, BE and OC meet at M, then M bisects AD, BE and OC. This is property of a regular hexagon. What is it? We are drawing the three diagonals of the hexagon AD, BE and OC meeting at point M. Okay, and they are bisecting each other. That is EM equal to MB, OM equal to MC and DM equal to MA. Okay, so we can say that point M bisects AD, EB and OC. Okay, AB bar is equal to, what is AB bar equal to? AO plus OB by triangle law of vectors. Okay, so we have AB bar equal to, now AO is the opposite of OA. We can see that clearly, right? So AB is basically, A is the initial point. So AO plus OB. So we can write this as minus OA plus OB. What is OA? We know OA is given to us as A. So minus A bar plus B bar. This is the value of AB bar. Okay. Now let's go to the next step. We'll say that OABM is a parallelogram. We can see that OA equal to AB, adjacent sides are equal, OM equal to AB because OABM is a parallelogram. So we write over here OABM is a parallelogram. Okay, therefore OM is equal to AB. OM is equal to AB. Okay, let's go to the next page. So OM will be equal to AB will be equal to, what is the value of AB we had? Value of AB minus A bar plus B bar, or we can say B bar minus A bar. So B bar minus A bar. Okay. Now OC bar, okay, is equal to, let's go to the diagram once again. OC bar is OM plus MC. Okay. So OC bar is OM bar plus MC bar. Okay, which is 2 times OM bar. Okay, which is 2 times B bar minus A bar. This is OC bar. So we have already got the vector OC. Now, next OD bar. OD bar is equal to OC bar plus CD bar. Okay, so which is equal to OC bar minus DC bar. Okay, now what is DC equal to? DC will be equal to OA. Okay, and OA is parallel to DC. In a regular hexagon, DC will be equal to OA. So we'll write, since DC equal to OA, or we can write this here. One second. We have DC equal to OA. Okay, therefore OD bar is equal to OC bar minus OA bar. Okay, which is, what is OC bar? 2 times B bar minus A bar. Okay, minus OA bar is A bar, which is equal to 2B bar minus 3A bar. Okay, this is OD bar. Now what is left with us? We have OE bar to find out. So let's write out the formula for OE bar. For triangle law of vectors, OE bar will be equal to OM plus ME. Okay, now OM we already found out, that is B bar minus A bar. Okay, plus ME can be written as minus EM. Minus EM, and now what is EM equal to? EM is again equal to OA because of EOAM being a parallelogram. So we write over here EM equal to OA. Okay. In brackets, EOAM is a parallelogram. Okay. Close the bracket. So what will be? We have OE bar as the final answer. OE bar is equal to OM bar, which is B bar minus A bar, okay, minus OA bar, that is A bar, okay, which is equal to B bar minus 2A bar. So we've got all the three vectors, OE, OD, and OC, that were to be found out. Okay, this is question 3. Now moving on to question 6. In the figure, express C bar and D bar in terms of A bar and B bar. Okay, so they have given you a particular figure. I'm doing question 6 now. So let's take question 6. Okay, they have given you a figure of a triangle PQR over here. Okay, and PS they have given over here. So this is PS. Now PR is given as B bar. PQ is given as A bar. Then we have PS equal to C bar. And QS and SR as minus D bar and D bar. Okay, so minus D bar and D bar. Okay. Now let's begin. PQ is equal to PR plus RQ. Okay. Now PQ can also be written as PS plus SQ, sorry. This is S, right? So in the smaller triangle, we can write PQ as PS plus SQ also. Okay, which is C bar minus D bar. Okay, then PR bar is equal to, again from the small triangle, so PR bar is equal to PS plus SR, which is C bar plus D bar. Okay, now adding equations 1 and 2, so we call this as A bar plus B bar is equal to C bar minus D bar plus C bar plus D bar. So we have the D bar vector cancelling out. We have 2C bar. Therefore, C bar is equal to, we can say, therefore, C bar is equal to 1 upon 2 A bar plus B bar. Okay. Substituting for C bar, we get, so now we'll remove C bar from each of the, in the given figure, express C and D in terms of A and B. Okay. So what we'll do is, we will substitute for C bar in equation 2, that B bar is equal to C bar plus D bar, so we'll remove C bar from there. Okay, so we have to write C bar is equal to B bar minus, okay, 1 second. From equation 2, we have, let's go back 1 second. From equation 2, we have B bar equal to C bar plus D bar. Okay, so we are going to substitute D bar as B bar minus C bar, which is B bar minus, now what is the value of C bar that we have got? Half A bar plus B bar. Okay, so half A bar plus half B bar. Okay, which is equal to B bar minus half A bar minus half B bar. Okay, so B bar minus half B bar is half B bar minus half A bar, okay, D bar. So finally we have D bar as half into B bar minus A bar. Okay, so we've expressed D bar in terms of A and B. Similarly, C bar is equal to, we already got, and D bar is equal to half of B bar minus A bar. Clear? So this is how you will substitute one in terms of the other. Okay, now moving on to question number 8. Find the distance for 4, minus 2, 6 from each of the following: the xy plane, the yz plane, the xz plane, the x-axis, y-axis, the z-axis. Okay, so let us begin. Basically, you have to use distance formula and get the answer for each one of them. So let us start with question 8a. Okay, so we're doing question 8. Point P, let us say what is the point 4 comma minus 2 comma 6. 4 comma minus 2 comma 6. Okay, now find the distance of 4 comma minus 2 comma 6 from the xy plane. Let the point be P4 comma minus 2 comma 6. Distance of P from xy plane is. Okay, modulus of z, that is 6 units. Okay, then yz plane will be modulus of x, that is 4, and zx plane will be modulus of y, that is 2. Okay, now distance of a from x-axis. I'm doing directly distance of a from, sorry, distance of not a, distance of p from x-axis. Okay, so that will be under root of y square plus z square, which is equal to under root of, what is the y coordinate? Minus 2. So minus 2 square plus, what is the z coordinate? 6 square. 4 plus 36 root of 40. Okay, can be written as 2 root 10. Again, distance of a from y-axis will be under root of x square plus z square, and distance of a from z-axis will be, excluding the z point, root of x square plus y square. Okay, that's how you will find out the distances. Now I'm going to an important question describing collinearity. Okay, so that is from question number 12. Show that the following points are collinear. Okay. So I'm doing question number 12 here. Okay, what's the question? Show that the following points are collinear. The first one, they have given A, B, and C. I'll just do the first one so you'll understand how to do the next one. 3 comma 2 comma minus 4. Okay. Then B is given as 9, 8, and minus 10. Okay. And C is given as minus 2, minus 3, 1. Minus 2, minus 3, and 1. Okay, so let us begin. How do we do this? So we'll say let A bar, B bar, and C bar be the position vectors of these points. So A bar is equal to 3i cap plus 2j cap minus 4k cap. Okay, B bar is equal to 9i cap plus 8j cap minus 10k cap, and C bar is equal to minus 2i cap minus 3j cap and plus 1k cap. Okay, that is, all these are expressed in terms of unit vectors. Okay, now AB bar, let's find distance AB. Now distance AB in vector form is given by B bar minus A bar. Okay, let us substitute that. So we have 9i cap plus 8j cap minus 10k cap, okay, minus 3i minus 2j plus 4k, okay, which is equal to 9i minus 3 is 6i plus 8 minus 2 is plus 6j and minus 10 plus 4 is minus 6k cap. Okay, you can take 6 common and you get I plus j minus k. Let us find out BC bar now. Okay, so BC bar is equal to C bar minus B bar. Okay, so vector C bar minus B bar will be minus 2i minus 3j. Okay, plus k minus 9i minus 8j plus 10k. Okay, so what vector do we get over here? Minus 2i minus 9i will become minus 11i, minus 3j minus 8k minus 11j plus 11k cap. Okay, we can take minus 11 common. Okay, so we are going to get over here I plus j minus k. Okay, this is BC bar. Now, if you can see AB bar and BC bar, then BC bar can be written as minus 11 upon 6 into 6 I cap plus j 6 j cap minus 6 k cap, okay, which is minus 11 upon 6 AB bar. That means I have expressed one vector BC in the scalar multiple of the other. So BC is a non-zero scalar multiple of AB. Therefore, they are parallel to each other. And if they are parallel to each other, then what we can say about the two vectors, that they are collinear. So, and also one more reason you can give over here, B is a common point between both the vectors, and therefore A, B, C are collinear vectors. Therefore, A, B, C are collinear. This is one method of solving it. You can also um, get distance AB, BC for the second part of the sum. Sorry, for PQR also you can do the same thing and get the vector. You can also use the position vector R cap and get each vector, that is, let's say AB, BC and AC in scalar multiples of R cap. Okay, so you'll have a constant, say X R cap, Y R cap and Z R cap, where X, Y, Z are scalar multiples, okay, and or scalar constants, and R cap is a position vector that I have considered, that is I plus J plus K. Okay, if I consider this, then this I can use to get the scalar multiples of AB, BC and AC. This is the second method to solve the same sum. Okay, this is about exercise 5.1. The important sums I have covered. If you have any other doubts regarding this, then you can mail me. I will solve it and send it to you. Okay, thank you so much.